Welcome back. It's Cody Hendrickson. We're going to take a look at databases again today. We're working on the operational side of them though, so you can actually see how to put stuff inside it. So we're looking at the CRUD, specifically the insert statement. We're going to be using the same slide for all the parts of the CRUD we're working through. So when we're talking about using the database, we have CRUD, which just describes the operations you do to most of the time when you're working the database. Today we're going to be looking at the create side. We're going to be creating or adding data to the table using the insert command. We've been working with the read, with the select queries, been doing all semester long. That's how we can actually retrieve data out of our database. We'll also be looking at update next time, so we can see how to replace the existing data. And also, we're going to be looking at the delete. How can we remove values out of the actual database? And so we're going to try and act like a dog because we want to exterminate all of the data we're working with. And so let's go ahead and take a look, though, at the insert statement, how to make that work right now. So when we're working with the insert statement, we're working about adding our data to our system. So we want to make sure we can actually put stuff inside our database. Our database is only good if we can actually make it dynamic and useful. So one of the main ways to do that is by adding data to it. So we want to add data to our database. We need to make sure we know the structure of our table. We need to know what's inside it. And so the best way to do that is to look for the DDL, or the data definition language, the code that's actually used to actually put together the database on the hand. And if you don't have access to that, look for an ER diagram, a way that actually describes what's going inside your database. And so those are the two best ways that we can use to identify how to actually put stuff inside a database, because we need to know what's inside it. When we're looking at that DDL or that ER diagram, what we're specifically looking for are some information components that we need to know so we can actually use that. The first thing we have to know is, what are the field types? We need to be able to know what can we put inside this database. We need to know, are we putting numbers, strings? Are we putting, for example, a calculated value that uses a decimal point? I know. But again, when we're working with databases, we're usually using things that can be easily inputted in with a keyboard for the idea of typing in. We're not going to actually store the binary files most of the time when we're working with databases. We may give an HTTP address for something so we can refer to an address or a network address to find some file on a drive, but we're usually just giving it irregular text-based values for what we're working with. So the field type, though, really important. You have to know that one for sure. The next most important piece is that field required? Now, if it were up to me, basically almost everything would be required, because I hate null. I know, it's ridiculous, but null a lot of the time causes a lot of problems when you're talking to programming land, and even in database land, because it becomes a bit of a problem. So I want to make sure whether or not do I actually need to type something into this field. Most of the time the answer is going to be yes, you have to do that. But if there are some things that don't require it, or if you're looking with an advanced database, you have some generated values. I know, it's amazing, they do happen. So you need to know whether you need to actually put something in those spots appropriately, and that's where we need to identify for that. The next most important thing, and this is this is at the top level as well. It's like, there's level one. These are all tied for first. But this is a foreign key integrity. When we're working on adding data to a database, we have to make sure, is it okay to actually add this data? If our table, if the field we're working with, that we're talking to, is referencing some other table and it's a foreign key that we're referencing to it, we have to make sure that whatever we put inside that field matches that foreign key. So this is where we have to actually look at the entire structure of the entire database and making sure we're keeping ideas in mind, so we actually put the right things, put the right data in the right spots. And so definitely make sure we keep our foreign key integrity taken care of with that. Now, the one thing about database land that's different from every other programming land is the parameter order doesn't matter. I know, it is a mind blower right here too, just for me. But because of the fact that we have to specify the parameter order ourselves, the parameter order we actually use doesn't matter, because one of the key concepts about databases is that the columns don't matter. The orders that we're putting in, it doesn't matter. As long as we use the columns we have to do, because we know if it's required or not, it can't be null. As long as we get all the columns we have to have in there, it doesn't matter what order we're doing in, because we specify when we first set this up what we're going to be putting them in. I know, it's amazing. And so this is one of the really cool things about database land. It makes it so different from everything else we're doing in programming fields. So really cool stuff, but these are the things you really absolutely, positively have to know. Now, here we have the actual single insert structure. Now, the single insert structure works on MySQL, MariaDB, Oracle we've been working with here in class all year, and even SQL Server. I think it even works in Postgres. I haven't worked with that for a while, but I'm pretty sure it's the same basic approach. And as you can see right here, when we're working with a single insert structure, we have the insert into. So insert's always part of the into command. That's, I know, great stuff. And they have spaces, so it looks like English. Cool stuff too. And then we have our table name. And then after the table name, we do our fields separated via comments. I made sure I use the word via here because by is a keyword, and I don't want to look really weird when doing the demo. I know. And then we have our values operator, and it says, oh, in parens, we are going to make sure we have all the types matched. So if I have 4 fields, I should have 4 different values being set up for that. Again, order matters in the fact that the make in the fields matches the sure and the separated, and the via matches the types, and commas match. Yeah. So making sure you have those matched, so making sure that those go like that. And so with this quick little demo right here, I just simply have them in a horizontal sequence. You can see the basic structure. Of course, they end with our great friend, the semicolon, but this is the basic approach when we're working with a single based insert on any of the database engines. So really pretty easy. Here we have an example right here of inserting into the student data. Here we have an example of inserting into the student table we've been working with this semester as part of the schema in the Oracle by example with the Richard text. And so as you can see right here, I'm doing all of my fields in a single row. I have all my fields, one field per row, because it makes it really easy to identify it. This is just like when we're doing our data members or our initialization sequence in a Java constructor, because this way I can check it off, boom, 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 boom. It's a great way for visual thing. Again, we're writing code for human beings, not for the computer, because the computer can handle it either way. And so again, I'm separating each field by a comma, and I have student ID, salutation, first name, dot, 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 dot. And almost all these are required to be valid fields to be put in there. They're not allowed to be nullable. And then we have on the same thing, we have a matching value. So student ID is a number, so I have 999 for the student number. Mix for the salutation, and then quacks for the first name, and quackers for my last name. So mix quacks is who we're going to be putting with and working on that, just like we've done in some of our other videos. And we have a little note right here. We have the zip. The zip is that foreign key. That's that integrity was just talking about. I can't just randomly throw in some random 5-digit value for a zip code. I have to actually use a zip code value that is real. And so I have to make sure I put in a value for, in this case, I've got 10015, someplace in New York that I don't particularly know where it is, but I have a valid number right here because that's what we're putting for as a reference in that, because we have to make sure we have our foreign key integrity anytime we're working with this. When I'm working with the idea of putting a date in there, for the examples we're doing for in this class, it doesn't really matter. I'm using sysdate, which is the Oracle command to get the current date right now. And then I did the created date of -120, so it actually was created 120 days behind me. Magic numbers, it's okay. And then when I modify it, I modify 123 days in the future. I know, it's pretty cool, but I can do that because of the fact that I'm just saying, hey, that's when I modified it. But those are all valid answers I can put inside there. And so that's how I can do an insert student into that table right here. And that's how I can add mixed quacks into our structure right there. So it's a great way to put some databases together and work with that. Now we can also give another example right here with a much smaller database. Here's one I made for the manga database. And so insert into products, and I have my unit price, my product name, my product ID. And then into values, I have 6.32, a yam, and 42, because 42 is a great number and yams are yummy. But if you look at the actual structure of the database, the product ID is the first column specified when you look at the actual DDL for it. But again, remember when we're talking about inserting into a database, the the column order doesn't matter. As long as I have all the required columns, which all three of them are, doesn't matter what order I do. I can do ACB, ABC, CAB, it doesn't matter. As long as I get all three values in there, I'm good to go. And that's exactly what we're doing right here. And of course, again, we end with our great friend, the semicolon. Makes life really easy. Now, multiple inserts are a little bit different. I'm only going to be giving an example here of the Oracle version. When you're working with a MySQL, MariaDB, or a standard SQL installation, you just simply have, after that first set of values, another comma, a parens, another set of values, all like them, boom, 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 boom. However, when we're talking about Oracle, and we have a new special way to actually do that. So Oracle, to do the compound insert statements, we do the standard insert into table name and fields, just like we've done before. However, when we're talking about adding a whole bunch of things, what we do instead is we use the power of that union all operator, where we can join things together, rows together as a giant chunk, and then we put that as a derived table and insert the values from that. So it's a little bit different, and so let's go ahead and take a look at that right here. So insert many, we have insert into cells, then I have my parameters and work with this, in this case cells ID, export ID, and cells date. And then with demo as, and that's where I'm specifying a derived table right here using those parens to identify the fact that I'm creating a table, and then I'm defining it as select 1, 3, 2, due date, creating a date value. And then from dual, remember it's that special table we can use inside Oracle that allows us to create values and calculate them on the fly. And then union all with the next result, next result, next result. But notice on that last line, it's just from do. I don't union anything like that because that's the end of the statement. I then close my parens right there, and then I do select everything from demo. So I've got that derived table, I've selected everything from it, and I'm just gonna dump it straight in. And so this is a very different way of doing it, but it's we can see how we can add a whole bunch of things using this way of structuring it by creating a derived table and inserting everything from that table into the database we're working with. And so it's a little bit different structure that we can use to make that happen. And so again, just do a quick little review right here. We have our single insert structure. Again, we're going to insert into the table name. We want to go to the fields separated by commas, and then the values themselves, making sure they match every single one right here. So if we look at this right here, my make matches fields, the sure matches separated, the types goes with via, and the match goes to commas. And so we have that approach we're working with for the entire time, and that's how we can go through and make sure we have this basic structure ready to go. Finally, again, just a quick review when we're working on adding data, we want to make sure that we know that structure. Again, take a look at the DDL or the schema or the ER diagram that goes along with that. Make sure you have that available with you. One of the things I recommend for my students is they have a copy of that right here with their hands so they can take a look at that as they're working with that. That's something a great thing to have on your second screen or monitor so you can always keep a look at that. I like having a physical copy because I can draw little notes, make sure I can keep track of the patterns and use that. And again, make sure you always keep track of what the field types are, whether or not those are required. Make sure you always maintain foreign key integrity. And then remember, because this is special, we don't have to worry about our order as long as they match across the things. That's it. Thanks again. Cheers and have a great day. See you next time. Bye-bye. Wub, wub, wub. Stop.